In this lesson, we're going to talk about some advanced sketch tools in SOLIDWORKS 2013, including the Conic sketch tool, which is only available in 2013. It's a brand new sketch entity. Most of the complex sketch topics that we've talked about so far have been concerning the spline tool. But there are some additional tools that you can use and access under the ellipse dropdown. These include the partial ellipse, the parabola, and the conic. Now, the partial ellipse and parabola have been around a long time, but the conic is a more general sort of tool, and it has some special concerns and special capabilities. Let's take a look at the three of these. In fact, let's just start with the ellipse. We'll just click on the front plane and Control-8 to turn normal to the view. The first click with the ellipse is the center. The second click is the end of one of the axes, either the major or the minor, it doesn't matter. And then the final click with the ellipse is the other axis. Unlike previous releases, you can swap out the major for the minor axis. It won't cause a crash. But the ellipse can be a little bit difficult sometimes to pin down. One of the things that you need to start doing is including a horizontal or a vertical relationship between a couple of the points. That will help you to lock down at least the direction so the ellipse isn't always rotating. Second, I'm just going to lock the center of the ellipse to the origin just so I can keep fiddling with it and it won't move. Now, you can see that the behavior is sometimes a little bit odd, especially if you have a horizontal relationship already set up. So just be aware that the ellipse is one of those things that's a little bit odd to control. So I'm going to click on that and delete it. Now let's show the partial ellipse. And the partial ellipse is created in the same way. I'm just going to create this one from the origin already, so we get that automatic relation. You drag out one of the axes, and then you drag the other axis, and then the final click is to create the included angle. If the regular ellipse is difficult to control, the partial ellipse is much more so, because not only do you have the angle of the ellipse to worry about and the major versus minor, but now you've also got the two endpoints of the open ellipse to worry about. So these things are best used in a more constrained situation where you have the ellipse tangent to something. Let me point out a couple of things. If you are using a version of SOLIDWORKS prior to SOLIDWORKS 2013 SP2, there's some things that you're not going to be able to do. And one of those things is, I've just added a spline here. If I select both of these, you are not going to have curvature continuity available as a sketch constraint between an ellipse and a spline. That's just one of those things. I'm working on SP3 here of 2013, so I've got this capability. Again, the limitation is SOLIDWORKS 2013 SP2 is where it was added, so SP1 and 0 will not have this capability. And also, any previous versions, such as SOLIDWORKS 2012, 2011, 2010, you're not going to have these capabilities. You can, however, in those previous versions, use the Make Tangent option, and that should work out well for you. So partial ellipse is a very useful tool, but we've got a couple more. The other one I want to show you is the parabola. The parabola has been around for a long time, but when it was initially released, it was very, very difficult to work with. And in fact, it was very slow. So it has improved over the years, but I still don't see that many people that use it. So this is how the parabola tool works. Click first the focus of the parabola and drag out the distance between the curve and the focus, and then click and drag for the included angle. It's maybe not very intuitive, and you probably will have to sketch this separately and then connect it to something. The interface for this particular item could have been a lot better. So click the focus, drag the distance to the curve, and then click and drag the endpoints. you could look at it as the included angle for the parabola. Now, the parabola is going to look a lot like the conic. In fact, even mathematically, they're related. The conic has a few advantages, and we'll just take a look at how this is created first. On this one, you click the endpoints first, and then you drag out the vertex, and then drag what's known as the row value, which you can think of as the sharpness of this sketch entity. If it goes all the way to the vertex, then it's a dead sharp. And if it went all the way in the other direction, it would be a straight line. The row value can be set in the property manager if you choose to. So there's a big difference in how these two entities, the parabola and the conic, are created. The conic, you actually start from the endpoints, and the parabola, you start from an unrelated point or a point that's not even on the curve. You're going to have the same issue with the parabola and the conic that we had with the partial ellipse. The C2 functionality is not going to be there on releases prior to 2013 SP2. So you might ask, what are the uses for all of these sketch entities? Here's a little background on these advanced sketch entities. I'll flip over to this conics part, which you can open from your Chapter 3 working files. And we're going to take this cone and section it with a plane. Now, if I section it with this plane 1, I'm going to get an ellipse. If I section it with plane 2, I'll get a circle. SOLIDWORKS even identifies this as a circle. If I section with plane 3, this is a parabola. Even though SOLIDWORKS identifies it as a spline right here, it's actually mathematically equivalent to a parabola. And as this angle changes from being parallel to the side of the cone to being parallel to the bottom of the cone, the shape of the cross section will change from a straight line at this point to a parabola to an ellipse to a circle. And a hyperbola would be demonstrated by a section such as this, where the section plane would intersect the cone if it were mirrored about the other plane. And so a hyperbola tends to have two branches, one in positive and one in negative territory. But the hyperbola is not a special sketch entity in SOLIDWORKS. The conic represents all of these, and the row value will allow you to go everywhere from a circle to a straight line. So with that, we'll flip back to our sketch, and we'll change the row value, just for practice, from 0.99, where we get a very sharp corner, to 0.01, where it's almost a straight line. And notice that SOLIDWORKS has automatically changed these values for me. It will go from 0.95 to 0.05. But if we go to 0.5, the shape changes accordingly. Conic section sketch entities are typically used in situations where you need to have a curve that changes curvature or changes radius, but you want something that's guaranteed to be convex to the same side in all places. A spline can get all S-shaped on you. So if you have a spline like this, it may look like a parabola or a conic, but you can have situations where the spline will be shaped like that. And this gives you an inflection point, which is a change in the convexity. So we can show the inflection point here. We can show the curvature cone, which definitely changes sides. But on the partial ellipse, the parabola, and the conic, you're guaranteed to have constant convexity. They're frequently used in aircraft applications and consumer products where you need to guarantee that you've got constant convexity and your surfaces or sketches don't have any inflection points.